All right, Math 2, Unit 7, Trig Functions. So there are three trig functions that we're going to deal with. We have sine, cosine, and tangent. They're normally abbreviated sin, cos, and tan. Now, sine, cosine, tangent is another way to talk about right triangles, and it's a way to talk about triangles that aren't necessarily the special right triangles, but we can say some things about them. Normally, the sine, cosine, and tangent are called trig ratios, where they're a fraction. So to put that into context with the fraction, you say, well, sine of x is opposite over hypotenuse. Cosine of x is adjacent over hypotenuse. And tangent of x is opposite over adjacent. We're talking about the sides in the triangle. So if we have a right triangle here, and you always have to orient yourself about an angle. Say we orient ourselves about this one. Then this would be our opposite, adjacent, and our hypotenuse. Adjacent means next to, so it makes sense that the adjacent would be next to the point. Now, some of that might be confusing, and there's lots of neat ways to explain it, but I'm not going to do that right now. I think we need to just kind of learn how to do it, and then we can kind of understand a little bit better later on. So these would be good things to remember. And the way that I remember it is Sohcahtoa, Sohcahtoa. So you split it up after every three letters. And then here we have sine, opposite, hypotenuse. Cosine is adjacent, AJ, over hypotenuse. And tangent is opposite over adjacent. So this is what I remember. And then after you do it, do a few worksheets with it, you'll just know them offhand. So the Sohcahtoa would be a good thing to have written down on another sheet of paper and have next to you so that you can reference it. All right. Number 2, find the value of each trig ratio. So it says cosine of A, which means we have to orient ourselves about A. So we are sitting at A, and we need to label our sides now. Well, our hypotenuse is going to be our hypotenuse. Opposite of A, and then there's adjacent. Cosine is opposite over, excuse me, that's not opposite, it's adjacent over hypotenuse, so 7 over 25. And that's it. It's just a fraction. We're finding the ratio of the sides. Number 3, tangent is opposite over adjacent. Now let's label our sides too. This is our angle. So here's our opposite, here's our adjacent, here's our hypotenuse. So opposite is 40, adjacent is 9. And if you can reduce, you want to reduce. This one you can't reduce though. All right, there's numbers 2 and 3. Look at number 4. Well, sine of C, from Sohcahtoa, we know that sine is opposite over hypotenuse. So we need to label everything. Here's our C, here's our opposite, here's our adjacent, here's our hypotenuse. Opposite is 14, hypotenuse is 50. This will reduce to 7 over 25. Number 5, cosine of x. So I'm going to orient myself about x. Here's my adjacent, my opposite, and my hypotenuse. Cosine of x is adjacent over hypotenuse, so 5 over 13. All right. Tangent of A, here's my hypotenuse, here's my adjacent, here's my opposite. tangent of A is going to be opposite over adjacent, 32 over 24. What will that reduce to? 17. That's not 17, that's 16 over 12, which is 8 over 6, which is 4 over 3. All right. And number 7, last one like this. We've got sine of A, so here's our A, here's our hypotenuse, here's our opposite, here's our adjacent. Sine of A is opposite over hypotenuse, so 21 over 35. And will that reduce 5, 6, 7, 8? No. And there we are. All right, so all we did on this first page is we found the ratio. Right? We're not actually solving for anything. We're just writing down the ratio. These should be pretty cut and dry for you. Number 8, here's where we actually start to use these ratios. So up here, what we said here is any triangle with an angle of A, say A was like 27 degrees or something like that, you could substitute something like that in, you would have this ratio of 21 over 35. So what we're going to say down here in number 8 is we're going to use the fact that we can say something about 62-degree angles. We can say, well, first we need to label what we have. This is the opposite, this is the adjacent. We don't have the hypotenuse, so we don't care about it. We need to pick which of the 3 trig ratios relates opposite and adjacent. There's only one of them that only has opposite and adjacent, and it's tangent. So I say, well, tangent of 62 degrees is opposite over adjacent 10 over x. Now, this guy, whenever we solve, you treat him like he's a single variable, a single term. So you can rewrite this as x equals 10 divided by tangent of 62 degrees. And then we need to type this in our calculator. One thing that we want to check on our calculator is that we are in degrees, not radians. So if you have a one of the graphing calculators, here, let me get it out. If you have a graphing calculator, you need to press the mode button. It's in the upper left corner. And about, when is that? 1, 2, 3, 4 ways down, it has listed radians and degrees. Those are 2 different ways to measure angles, like 2 different units, like meters and yards. No, not really, but that's, for this purpose it is. We want to make sure that we have degrees highlighted. So if you need to, make sure that degrees is blinking black and white. At least that's the way it works on my calculator. And then press enter, and you can press clear. So what I'm going to do is here is I'm going to type in, well, 10 divided by tangent of 62, and x is 5 point, I'll round to 3, 2. Do I need to round to the nearest, tenth, so I'll say 5.3. All right. Almost all of these will give you very ugly decimals, and that's okay. So again, what we said here is all triangles with a 62-degree angle have the same ratio of opposite and adjacent. So here, this thing here is a fancy way of writing a proportion or a ratio. So we're doing something along the lines of like A over B equals 10 over X, where A and B are known. All right. If you just type into your calculator tangent of 62, you get 1.88 and a bunch of other stuff after that. So we're saying 1.88 is the ratio of the opposite over the adjacent. All right, let's do another one. Number 9. Again, here is our angle, here's the opposite, and here's the adjacent. You always want to label what you know. You don't really care about the piece that you don't know about. This one, again, opposite and adjacent is tangent, so tangent of 62 degrees is equal to 13 over x. we can swap our x and our tangent and say, well, x is 13 divided by tangent of 62 degrees. And then I take my calculator and I say, well, tangent, oh, excuse me, I say 13 divided by tangent of 62 gives me 6.9. Right. Another thing we can say is both of these have 62-degree angles and they both use tangent. So we really said that these two triangles have the same ratio of the opposite over adjacent sides. And now there's some neat ways to explain where did the ratio come from, but I think we need to be able to use the ratio before we can really start to enjoy why it is. All right, number 10. So we orient ourselves about this angle here. This is going to be our hypotenuse, and this is the side opposite. So we need a trig ratio that relates opposite and hypotenuse. The only one that does that is sine. So sine of 47 degrees equals x over 12. This one's kind of nice because my x can stay put. I'm going to multiply by 12, and I say, well, 12 sine 47 is x. Also, one other thing, and I don't know if I've said this yet, it is sine, not sin, and cosine, not cos, and tangent, not tan. Right? Say the whole name. You don't have to say sin, you can say sine. It's not that much longer. All right, we have this thing written here, and now I can type in my calculator 12 sine 47. And I got 8 point, all around and say 8. All right, there we are. Number 11. I orient myself about this angle here. Here's my opposite. Here's my hypotenuse. So I'm going to say, well, sine of 43 degrees is 11 over x. My x and my sine switch spots, and I say, well, x is 11 divided by sine 43. 11 divided by sine 43 is 16.13. Well, I guess I'm supposed to do one decimal, so 16.1. All right, last ones. Here's our angle, here's our hypotenuse, here's our adjacent. So I'm going to say, well, cosine of 41 degrees equals 15 over x. So x is 15 over cosine 41, and 15 divided by cosine 41 is 19.8. Oh, I guess it's 19.9. All right. Number 13. Here's my angle. Here's the side adjacent. Here's the side opposite. We decide which of the three we use, and this is going to be tangent. Tangent is the only one that has only opposite and hypotenuse. Only opposite and adjacent. So I'm going to say, well, tangent of 67 is 15 over x. So x is 15 over tangent 67, and 15 divided by tangent 67, 6.4. All right, there we are. There are the standard trig ratios.